Okay, so our next section, we have a few new theorems here. So the first one is just the comparison property of equality. So that's just saying that if A equals B plus C, then C has to be greater than 0 and A is going to have to be greater than B. Our next theorem is the corollary to the triangle exterior theorem. So we've worked with the exterior angle theorem, and that would say that the two remote interior angles equals the exterior angle. So in this case, angle 2 plus angle 3 would equal angle 1. So the corollary to that is that the measure of the exterior angle has to be greater than the measure of each of its remote interior angles. So basically, angle 1 has to be greater than angle 2, and angle 1 has to also be greater than angle 3. The next one is if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So if angle A is greater than angle B, then side BC would have to be greater than side AC. And the last theorem in this section is the triangle inequality theorem, and that says that the sum of any two sides of a triangle is greater than the length of the third side. So the example here, xy plus yz, that would have to be greater than xz. So those are cases to have a triangle. So we're going to look at a few examples. So the first example says which side is the longest. And by looking at this, we can see that side BC is the longest. It says which angle is the smallest. So again, we're looking for our shortest side, which is BC or BA, which is 4. So opposite angle of that is angle C. So angle C is the smallest. And then number 3 says, can a triangle have sides of lengths 4, 5, and 10? So this is where that triangle inequality theorem is going to come in. We're going to have to show that 4 plus 5 is greater than 10, 5 plus 10 is greater than 4, and 10 plus 4 is greater than 5. And of course, these two we know are correct, but since this is not true, 9 is not greater than 10, that does not satisfy the triangle inequality theorem, so those cannot be side lengths of a triangle. And then the last example here is a triangle has side lengths of 4 inches and 7 inches. What are the possible range of lengths for the third side? So I'm going to work this out on a separate page so I have some room to do work. So we're trying to find the lengths of the third side. So our 3 sides, we have a side that is 4 inches, a side that's 7 inches, and then a side that is x inches. And again, we want to satisfy that triangle inequality theorem. So we're going to write 3 inequalities. So the first one would say that the side x plus 4 would have to be greater than 7. The next one would say x plus 7 would have to be greater than 4. And then the next one would be that 4 plus 7 would have to be greater than the side length of x. So now if we solve these inequalities, for this one we get x is greater than 3. We get x is greater than negative 3. And here we get that 11 is greater than x, or if we flip that around, x is less than 11. So what we're going to want to do now is write an inequality with that. So if we're thinking on a number line, I've got negative 3 here, 3, and then 11. And I know that x has to be greater than negative 3, but it also has to be less than 11. So when I write my inequality, I don't really have to put the 3 in it because just being greater than negative 3 and being less than 11 covers this first one here. So when I write my inequality, I can write negative 3 inches. And then I'm going to put x has to be greater than that. So make sure that your greater than symbol is facing towards x. And then less than 11 inches.